Okay, in this video we're going to look at end behavior of a polynomial, and then we're going to look at zeros and how end behavior and zeros of a polynomial are actually going to help us graph a polynomial. And so let's just talk about end behavior first. In end behavior, I'm literally talking about what's going on at each end of the graph. So let's look at one that's familiar to us. So we've got y equals x squared. So this is kind of my go-to example because everybody at this point, please know what's going on here. This is the parent graph of a quadratic function. And we know that it is opening up with vertex 0, 0. And that's just a rough sketch. So when I'm talking about the end behavior, I'm literally talking about what's going on that end and what's going on that end, each end of the graph. And so the notation I'm going to use here is I want to know what's going on as x goes to negative infinity. So as x goes in that direction, what's going on with the polynomial. And I want to know what's going on as x goes to positive infinity. So as x goes this direction, what's going on at the polynomial. All right, so we're looking at the end behavior, like I said. Well, if we notice as we go to negative infinities, our x value gets smaller and smaller and smaller. Y is getting bigger and bigger and bigger, going up. So since this parabola is opening up, we say that as x goes to negative infinity, y goes to positive infinity. All right, on the other side, we say that x is going to positive infinity. What's happening with y is x gets bigger and bigger. As x gets bigger and bigger, y gets bigger and bigger. So we say y is going to positive infinity as well. All right, so this is the notation that you're going to use for end behavior of a graph. All right, now if I look at y equals negative x squared, well, the same thing's going to happen here, except this parabola is going to open down. So if I want to describe the end behavior, so I'm looking at what's going on as x goes to negative infinity, what's going on as x goes to positive infinity. Well, as x goes to negative infinity, y is getting, so x goes to negative infinity, y is getting smaller and smaller and smaller. So I'm going to say y is going to negative infinity. As x goes to positive infinity, y is getting smaller and smaller and smaller again. So y is going to negative infinity as well. All right, now let's look and see what happens. Let's look at another graph. Let's look at y equals x cubed. All right, so this is just another basic graph that you probably know the parent graph looks like. So that's just that little S-shaped graph looking like that. All right, so same thing here. If I'm going to describe the end behavior, I want to know what's going on that end, what's going on in that end. My notation is x goes to negative infinity. What's y doing as x gets smaller and smaller and smaller? Well, y is getting smaller and smaller too. So y is going to negative infinity. And as x goes to positive infinity, you can see that y is getting bigger and bigger and bigger. So y is going to positive infinity. All right, let's do the same thing that we did with the other function, and let's make it negative. If I make it negative, well, how am I transforming that graph? Well, I'm just reflecting it. All right, so now as x goes to negative infinity, y is going to positive infinity. As x goes to positive infinity, y is going to negative infinity. All right, so this is going to be key to figure out all the end behavior of any polynomial. And really, if you know these two functions, you're pretty much going to be good to go with anything else. And I'm going to show you why. Because if we know that the degree of the polynomial, let me scroll back down here. Notice that this is an even degree. And what's happening with an even degree, it's opening up. If it's positive, and that you remember that from the last section, if a is positive, this is a parabola opening up. This is going to be true for any even degree polynomial. They're either going to be going up, the end behavior is either going to be going up, or both of them are going to be going down, depending on the sign of the leading coefficient. With an odd function, they're going to be going in the opposite direction, and that is also going to depend on the sign of the leading coefficient. So let's look at number 10. All right, so we've got some polynomial, they just call it q of x, equals negative x squared times x squared minus 4. All right, so let's look at this. Well, this isn't multiplied out, and you don't really have to go to the trouble of multiplying the whole thing out, because all you need to focus on is the degree of that polynomial and the sign of the leading coefficient. So if I distributed that, I would get negative x to the 4th, blah, 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 okay? All right, so this is what I need to know. I need to know the degree, it's even, and my leading coefficient is negative. So what does that mean? Well, it means that if I just visualize this graph, that the end behavior is going to be opening down. It's going to be opening down because that, and then you don't really care what's going on in here. All you're worried about, if I ask for the end behavior, is what's going on at the end of that graph. Well, the end of that graph, as x goes to negative infinity, y is going to negative infinity. As x goes to positive infinity, y is going to negative infinity. All right, and I knew that based on the degree, it's even, and the leading coefficient was negative, so I knew this was opening down. All right, let's look at another one. So this is 11. So this is negative x to the 5th plus 5x cubed minus 4x. All right, same thing here. I'm looking at this. I didn't have to multiply out. I can see the first term. It's negative, and my degree is odd. All right, so if I know what an x cubed looks like, then an x to the 5th, that end behavior is going to be the same thing. So remember that if it were positive, it would be doing that, right, at the end behavior. This is negative, so I have to reflect that. So this graph is going to be doing that and that. And like I said, we don't care what's going on in between. We're going to talk about that in just a minute. But all I need to know for the end behavior is that x goes to negative infinity. So x gets smaller and smaller and smaller. Y is getting bigger and bigger and bigger. As x gets bigger and bigger and bigger, y is getting smaller and smaller and smaller.